Welcome to this lecture. In this lecture, which is on first order systems, chapter 3, part 21, we'll discuss two terms, namely resistance and capacitance. So, resistance and capacitance are associated with the first order lag. They are characteristics of first order process, first order lag. A first order lag, what causes the first order lag? What causes resistance and capacitance? The presence of resistance and capacitance in a system makes it as a first order lag. So we'll see what is resistance and what is capacitance and how are they related to first order transfer function. Now capacitance is defined as the ratio of change in storage of a quantity to change in driving force, or you can also define it as change in storage of a quantity per unit change in driving force. So this is definition. Change delta represents change, so it's a ratio of change in storage to what? Change in driving force. So the ratio of these two terms, change in storage and change in driving force, or you can consider it as change in storage per unit change in driving force, either way. Similarly, resistance is defined as the ratio of change in driving force, delta driving force. Delta means change in driving force and change in flow. The ratio of these two quantities, change in driving force to change in flow. So the ratio of these two terms, change in driving force and change in flow, is known as resistance. Or you can also define it as change in driving force per unit change in flow. So every first order process has got these terms, these three terms: storage, driving force, flow. For example, if you consider thermometer, what is the storage quantity? Stored quantity. Storage means whatever is stored quantity, storage or stored quantity, same. What is the storage? What is the stored quantity in thermometer? The internal energy. In thermometer, stored quantity is internal energy. And for the same thermometer, driving force is the temperature, right? The temperature is the driving force. And what is the flow in thermometer? What is flowing in thermometer? The heat. Heat flow is taking place. Similarly, if you take a mixing tank, what is storage quantity? What is stored quantity? The mass of the solute. The mass of the solute is the stored quantity. And the driving force is, what is the driving force in the mixing tank? Concentration. And flow in mixing tank is the solute flow of the solute through the tank. So like this, every process will have a storage quantity, have a driving force, and you have flow. So these capacitance and resistance are related to these terms by these equations. Now the time constant of first order process is equal to the product of resistance and capacitance. Time constant tau equal to R. R stands for resistance, C stands for capacitance. R stands for resistance R, and capacitance C. So time constant is the product of these two terms, R and C. R for resistance, C for capacitance. R is resistance, C is capacitance. So the first order time constants will be the product of the two terms, R and C. So and therefore the first order lag is also known as RC lag. First order lag is RC lag. By the way, in electricity, in electrical circuit, you have these terms. In electrical circuit, RC circuit, you have resistance and capacitance. So that is the basis for the terminology used here. So that is also RC lag. So that also will have an RC lag, RC circuit, first order lag. Anyway, we are not here, we are concentrating on chemical process. Anyway, that is the basis. That RC in electrical circuit is the basis for using them here. So first order lag is also known as RC lag. And this R time constant, we have been seeing earlier as a units of time, seconds, minute or hour. So accordingly, the R and C also will have units, dimensions, depending on the process. Now I'll give you a question, try to find the answer. Identify the capacitance term and resistance term, C and R, in thermometer, CSTR, mixing tank, and the liquid flow through tank. So each one of them is first order. Find out what is the term which represents capacitance, which represents R. For example, let me do it for this liquid flow through tank. So let us consider liquid flow through tank. So let me illustrate these terms C and R for one particular case, liquid flow through tank. We have derived this, we have discussed this in detail in PC48, right? If you see PC48, we have discussed this. Now, let me find out what is capacitance and this C equal to delta storage. What is storage in the liquid flow through tank? It's a volume, right? It's the volume of the tank, volume. And driving force, what's the driving force for the liquid flow flowing through a tank? That is simply the liquid height, liquid head, height of the liquid. So delta, change in volume per change in height. What is this known as? What will be this? Volume by h. Volume by height is the area of cross section A, right? Volume by height is change in volume, change in height is area of cross section of the tank. So for the tank, the capacitance is nothing but the area of cross section A. Now let us find out what will be the resistance in that same tank by using this for same liquid flow through tank. Liquid flow through tank. Find out the resistance using the same formula for tank. Resistance is change in driving force. Driving force is for the tank is the head, liquid head, H, and flow is Q, volumetric flow rate. So delta H by delta Q, and if you have a linear relation, delta H by delta Q is the same as H by Q. So R equal to H by Q. So you get this resistance for tank is H by Q. And if you recall our discussion and derivation, we have taken Q equal to H by R in the derivation of transfer function for tank. Both are same. So R equal to H by Q by this equation, and it's the same as Q equal to H by R. And what is the time constant that was shown to be for the tank, liquid flow through tank? What was the time constant that was shown to be in the discussion in the derivation of transfer function? So in the transfer function, the time constant for the tank was A into R, right? A into R. So that is the same here. Tau is R into C, product of resistance and capacitance. A represents capacitance and R is a resistance. So the time constant is a product of the two terms R and C. So similarly, you can find for the other systems. For thermometer, it was discussed in PC36. My lecture titled as PC36, CSTR in PC49, and mixing tank in PC50. So for each of them, you will have a term. For the time constant, you will have a term, one representing capacitance and other representing resistance. and the product of these two, C and R, will give you the time constants. So have a look into this question and try to find the answer. If you have any comments, please leave in the comment section. Stop here. Bye.